Hello Algebra 2 students. This is the first video for lesson 1.3 for example 1. Since it's the first one, let's see what the essential question is for this section. How do you model a situation in which a function behaves differently over different parts of its domain? Piecewise defined function and step function are the two vocabulary terms, and in the end you'll be able to graph and interpret piecewise defined functions. I mean, that's what this section is all about. Skipping over the model and discuss, we'll go to example 1. Model with a piecewise defined function. Let's see what they have for us.
Alani has a summer job as a lifeguard. She makes $8 per hour for up to 40 hours each week. If she works more than 40 hours, she makes 1 5/10 times her hourly pay, or $12 per hour for each hour over 40 hours. How could you make a graph and write a function that shows Alani's weekly earnings based on the number of hours she worked?
So she's got two different rates going here. It's $8 an hour for the first 40 hours, and then after 40 hours, she's making $12 an hour. Remember that? Yep, that's what we just got right there. Solution. All right, so they graphed it. For 20 hours, 25, 30, 35, 40, it's a straight $8 an hour. And that's these red dots, and you can see the slope of that line. And the slope is actually the 8. But then once she hits 40 hours of work, any hours after that, she's going to be getting $12 an hour. So they put in for 45, 50, and 55. They put in how much that would be. So you can see it's in two pieces. Step 2. Notice the plot contains two linear segments with a slope that changes slightly at x equals 40. A function that has different rules for different parts of its domain is the vocabulary term piecewise defined function. That's what we have here. We have two pieces, so it's a piecewise defined function. Two distinct things, two separate types of equations. Step 3, you write an equation for each piece of the graph. So when x is more than 40, I don't know why they started with that one. I would start with this one first, because it's the easier one. From 0 to 40, Alani's pay is just $8 an hour. So that's 8x. The equation of the red graph, the red line, is 8x, and that's from 0 to 40 hours. And then once it gets past the 40, you got to have this total plus any hours after that. That's the trickier one, so that's the one I would have done afterwards. We already have the $320. It's not letting me highlight it. We already have the $320 that we got at the 40-hour mark, plus $12 an hour for any hours over 40. And then if you distribute the 12 and then add the 320, you end up with this. So they kind of skip that middle step. You may want your teacher to go over how to get that equation there, but it's really just distributing the 12 and then combining like terms. Conclusion, we can break it into two pieces, and this is what a piecewise function should look like. You start off with p of x, because they said the amount she's getting paid in terms of hours equals, then you have the bracket, and it's got two pieces. The equation is 8x, I can't highlight it again, it's 8x for 0 to 40 hours, and then if it's over 40 hours, it's this one, 12x minus 160. This notation is used for piecewise defined functions to indicate the different functions of different parts. So this is the general format you'll have. You'll have the equation for this domain, and then the equation for this domain. Let's see, do they have another example for us? Nope, they're going to have us jump right into doing a problem.
Alani has a summer job as a lifeguard. She makes $8 per hour for up to 40 hours each week. If she works more than 40 hours, she makes 1 5/10 times her hourly pay, or $12 per hour, for each hour over 40 hours. Part A. How much will Alani earn if she works 37 hours?
Okay, I didn't realize it was going to be the same problem. I wouldn't have played that. I apologize. Okay, 37 hours. How can we figure out how much she's going to get paid for 37 hours, and then part B is for 43 hours. So click pause, try to figure those out. If you need to, you can rewind the video, go back to the two equations. Here are the two equations to help you out. All right, for 37 hours, we just plug it into the equation. It was 8x, right? So 8 times 37. And let's see what that is. 8 times 37. 296. Yep, 296. And then for the 43, the equation was the 12x minus 160, so I'm going to plug in a 43. 43 times 12. 43 times 12 minus 160. It looks like she's getting $356. 356. Let's see what the right answer was. $356. Okay. From that, you should be able to do the following problems: 15, 22, and 23. That's it for this video. Have a great day.